necessarily have to convert, and in fact measuring milliliters is what I'm going to do, so I'm going to keep my units as milliliters there. So on this side of the equation, I have 15.0 molar for my concentration. My volume is what I need to figure out. And that will tell me how much of that stuff I need to measure out to dilute to get what I want. So then on this side, I know my concentration and molarity, 0.10 molar, and I know my volume is 50.00 milliliters, right? So now I've got the concentrated stuff, the less concentrated stuff. I can solve for my unknown at this point, so I just do 0.1 times 50 divided by 15, and I get my volume as long as I'm super careful to get it in the right units.
What about the 2's on the diluted side?
That just means the second molarity and the second volume. So first molarity, first volume equals second molarity, second volume. So anyone have a calculator and can tell me volume 1? Everyone will need a calculator within minutes, so go for it.
So you want this in milliliters or liters?
Well,
Because I have both.
I want it in milliliters because
Okay.
I'm going to measure in
So
milliliters.
I have 3.33 milliliters.
And I get 0.33
And
milliliters.
tops like fine.
Anyone else? We got to make sure because I don't want to make the
I
solution
have
wrong.
0.33.
And I have 3 here, 2 here, 3 here, so I can only keep 2.
Oh, I see what you're
Okay, so B1 tells us about the concentrated side, right? So it's telling me 0.33 milliliters of the concentrated stuff. So now that I did the math, how do I make the solution?
I'm going to keep adding water to the 0.33 milliliters until you reach 50.00 milliliters.
Add distilled water to 0.33 milliliters of 15.0 molar ammonium hydroxide until the total volume is 50.00 milliliters, which is the flask I have. So, how do I do that? Okay, next week you'll be doing some of this. This is called a pipette. It's a much more precise way to measure than a graduated cylinder. How could I measure 0.33 milliliters in a graduated cylinder? It doesn't even have a line until 1 usually. Right, so there's no way I could get that right enough to have a decent solution. So before I start, I'm going to open this little bottle up all the way, not spilling it in my tea at all, so that I can pour it in when the time comes. Then I'm going to use this as a volumetric flask. It only has 1 line on it right there, and that is, yeah. Just put this over on the windowsill. I don't want to drink that later. That 1 line is exactly 50.0, hopefully 0 milliliters. This is a bulb that sucks the stuff up into the pipette, and clearly, since I'm not going to use a ton, I'm going to pour some out, actually maybe even into a test tube, and not contaminate my stock bottle. Super concentrated base. Does not want to open. Really. Okay, goggles would be awesome. I can see like stupidity happening next. Thank you. You guys don't need them probably. I'll keep it over here. But you know, eyes are good, and splashing 15 molar base into eyes Okay, maybe we're not doing a whole lot of solution making today.
Is it one of those push down and turn
I am pushing down, but it's not coming off.
Or sometimes if you like hold it down with one hand and then actually turn it with the other hand.
While pushing down, turn this way. That's what I'm doing. Is that video right? Because I swear we need to delete that right now. This is not
It is actually.
great.
No,
That one
Jenny
is
should just make a
gone.
bloopers called chemistry bloopers. Put it on YouTube. It'd be great.
There's a really good one already on YouTube where I shot the person sitting in Maddie's seat with a cork. That's the hot seat right there, quite literally. The scariest lab I do all year. I don't think it's going to open. Maybe I'll move my phone too.
Do you want one of us to try if you can do it?
No. Although I don't doubt at all that you could do better. I can make my own kid do it. She can't see me. I love you, but you're pretty strong. It just won't come off. This is crazy.
Yes.
I'll have solution making in physics. I'll use them. And I'm definitely deleting the video.
But
Just turn that
delete
thing
that.
off. I don't know how to do that. So anything you get is always uncut on YouTube because I don't know how to edit videos. This is insane. Oh, I think I got it. Okay, now oh, it smells terrible. Woo, boy. Also, whenever you need to smell something in the lab, you waft. You never fork up a bunch in your nose. Still deleting that video. So, now I'm going to practice for a second because using the bulb is something I do twice a year and I never remember how. So you have to evacuate the air from your bulb and then you're just going to suck up a little bit. So I need, this is a 1 milliliter pipette. So if I sucked up all the way through the lines, I would get 1 milliliter. So I'm going to suck up 1, 2, 3. Well, actually, I'm going to suck up a whole bunch, and then I'm going to dispense the right amount. Yep, and dripping 15 molar base on my finger. Somebody get the vinegar out, please. Here.
Are we allowed to get close?
The lid's back on now, I think. Actually, my finger's not hurting yet, so. Be alright. I don't know if that is quite enough. Did my bulb stop being empty?
Yeah.
I can never remember which button to push. When you're in college, you won't use this ridiculously ancient but yet cheap little bulb. You'll get a real thingy that works. For real? Okay. It just doesn't work at all. Okay, so they used to do it by mouth. The great scientists of old, which I will never do. I do not love this solution nearly enough to make, suck on the end of this pipette until I get some 15 molar ammonium hydroxide in my mouth. 'Cause I like tasting and living. Okay, so it's sucking up the horribly stinky ammonium hydroxide. Okay, so now the problem with pipettes sometimes is that they, where's my flask? Cute little flask, there it is. Okay, so pipettes, you have to think, next week you'll have to think. So I'm at, let's see, 5.5, I'm going to dispense 3.3 mils of this. So that's half a mil, and I'm reading a meniscus. Not half a mil, but 1.5, 2, 2.5. My hand is tired. 3. So I was counting like 1.5, 1, but it was really 0.33 mils, not 3.3 that I dispensed, because the whole thing is only 1 mil. And I want to get this off so I can't tip it over. Then I want to dump a bunch of vinegar on it to neutralize it, I think. And then my hands. Okay, pick up the tape. And, oh, the bottom of the whole thing is slimy. Awesome. Okay, I'm going to wash my hands with vinegar and then we'll make the solution.
Did you request this room purposefully so you have that window? Did you request this room so you have the window?
No, but I'm happy to have the window. Definitely, very happy. I wish I had 20 years ago skin, since I'm wearing 25 years ago outfit, because my skin's all cracked anyhow. Okay. So, now that I finally managed to use a pipette properly and get 0.33 milliliters of ammonium hydroxide in there, now I just dilute up to 50 mils of distilled water. I'm going to rinse the very neck here really carefully. So then once you now when you dissolve a concentrated base or acid, it will give off heat. So since that's a tiny amount, it doesn't matter. But when you're making solutions, you want to account for that. You don't want to use glassware that has a little flaw or a little crack, because the heat given off will just make it break everywhere. Ask me how I know. So, once it gets right up to that line, then I read the meniscus, and I do swirl occasionally because very concentrated acids and bases are very dense and hard to get up off the bottom if you don't swirl. And then you get your solution up into that neck, and then you can't swirl anymore. So, I just wanted you guys to see solution making once before you did it, because you don't get the, if you don't see somebody do it, you don't really get the whole thing. It also takes a little time to drip down the neck, so it's easy to overshoot this. Ooh, okay, so my meniscus is exactly 1 drop away from perfect. And you know, if I do 1 more drop, it's going to be like, okay. So then I find the lid, put it back on, give it a good shake over a waste bucket so I don't spill it everywhere. Oh, I bet it's still in here. Yep. Okay. So, pipette, volumetric flask, the only way to make solutions. So I get it really well mixed, and then I refill my bottle, and I've got my nice dilute solution of base. Good. Okay. And I have to wash that anyway, so here we go. Solution making complete. Awesome. Now I'll throw the rest of that out because I only can fit this much in a labeled bottle. Always label everything. Don't leave unlabeled bottles laying around the lab. It's unsafe and weird and scary for people.
Especially if you need them, because then somebody might see an unlabeled bottle and throw it out. And
I know.
if they throw it out without thinking, then it might be something that'll eat whatever they throw it out in.
Chloride they just threw away, you know, was what you needed tomorrow. Always bad, always bad. Okay, so we did some solution making. Now let's do the math we're supposed to do today and hope that the paper towels don't literally disintegrate from getting nitrate on them. Okay, I'm going to double check that this bottle is really closed. See it being really closed? Yes. Okay.
That bottle's enough to make a lot of solution.
What?
It's enough to make a lot of solution.
Yes, because I mean, like the solutions that I would use, I only need the tiniest bit. So I don't want to store it in there. Oh, I'm just going to store it in here for now. It's nice and safe in there. Okay. Yeah, when you buy the little kits from Home Science Tools, like think of how tiny bit he uses to do stuff. It's probably a good deal. I should start making chemistry kits for extra money. Dr. Weil plated silverware with waste silver nitrate or something in college for people so that he could make money. All right, so we're on practice problem 1, and we left off with Jenny. All right. I need a deep breath after touching that stuff. A chemist mixes sulfuric acid with aluminum hydroxide, gives a balanced equation and that represents the resulting reaction. So,
Hang on, my thing is I'm still losing my voice, but my thing is upside down.
hopefully after you do
Because
the
you can't
solution,
put pages.
I know, I can't copy pages. Hopefully you guys, when you see the solution making problems in the book, it will help you to have actually seen solution making. I hope I don't take the surface off the board. Okay, so Jenny. So sulfuric acid.
Are we gonna balance it, or should I just?
Just tell me what sulfuric acid is.
H2SO4 is what I had first.
Is that video still running?